All right, welcome to the sample final exam review. In this review, I'm going to talk about each problem, how I solved it, and what I might change on the real final. All right, we're looking here at the sample, questions 1 through 8. You're going to take one of our basic graph shapes, move it around somewhere. You're going to label where did the main point get moved to, and if it has any horizontal or vertical asymptotes, you're going to list those as well. And finally, you're going to write the domain and the range. All right, so 1 through 8 are that way. Basic shapes: x squared, x cubed, square root, cube root, absolute value, 1 over x, exponential functions, log functions. In question 9, we're going to graph a piecewise defined function. And again, you're going to label especially what happens at the transition points. All right. Question 10, you are given two functions, and you're going to determine are they inverses or not. And you can't just say yes, they are, no, they're not. You have to prove that they are or they are not. In question 11, we have a banking problem. We have some money being invested quarterly, and it's going to stay in the bank for 5 years. So this is one formula you do need to memorize. In questions 12, 13, and 14, we have inequalities to solve. Normal inequality, an absolute value one, and a quadratic one in 14. In question 15, you're going to do division, and you can pick which one you like, whether it's long division or synthetic division, and then you're going to rewrite whatever your answer is. In question 16, we're solving something. 17, solving a exponential equation. 18, we're solving a log problem. In 19, we have a system of equations. We're going to solve it by the matrix method. If you solve it by a different method than the matrix method, you get 0 points. And finally, in question 20, you're going to draw a rough sketch of this polynomial. The important points are what happens on the far left and the far right, and what happens at the 0 points. All right, so let's start looking. Question 1, we have f of x is x plus 3 squared plus 4. All right, so the basic shape is x squared. It's a u. I'm looking in the front. There is no minus, so it's looking up. It's not flipped. The 4 on the end means I get moved up by 4. The stuff on the inside is a left or right. And so you set it equal to 0 and see it does go left. All right, so normally we were crossing at 0, 0. It moves right, left by 3, and then up by 4. So the important point is at minus 3, 4. The domain for all polynomials is everything. The range is how low to how high. Well, it goes as low as 4 and then up forever. How could I change this on the real one? Well, I could make this x minus 2 minus 5. So various adding and subtractions to move it around. Question 2, we have our x cubed, which is a snake, so it looks like a basic shape of a snake. There is something out on the end, so that moves things down by 2. There is nothing with the x, so there's no left or right. All right, so we have our basic graph, where it got moved to. Domain and range for this function is everything. Question 3. All right, question 3, we have our square root as a basic shape. So it looks like a little swoosh going off to the right. There's nothing outside of the square root, so there's no up or down. It's all under the square root. That means it's a left or right. Set it equal to 0, and you see that would be minus 5. So we got moved left by 5. New important point is minus 5, 0. So the domain starts at minus 5. It does include it with a bracket. Goes off to the right forever. The range, how low to how high? That is 0 to infinity. Question 4. We have the cube root function. So we have our basic shape for a cube root. I see there is a number stuck out there on the end, so that's a up or down. And it moves my basic shape from 0, 0 up by 4. And so now it's at 0, 4. No left or right. The domain and range for the cube root is always minus infinity to infinity. Question 5, we see the basic shape is a v, which is absolute value. The plus 1 on the end means it goes up by 1. Stuff on the inside is a left or right. Set it equal to 0, and we get x equals minus 3. Domain is everything, always for absolute value. Range, well, how low it gets is now 1, so it goes 1 and up forever. Question 6, we have f of x is 1 over x. I know that that is undefined normally at 0. So it will have a vertical asymptote, and it will have a horizontal asymptote. All right, but I'm looking here. There's nothing out here, so there's no up or down. The movement is in this piece. So x minus 4 equals 0. I get x equals 4. So we are shifted right by 4. All right, so we do need to label the vertical asymptote here at x equals 4. Since there's no movement up or down, the horizontal stays the same, which is y equals 0. So the range is just like 1 over x. The domain is different because it got shifted over to 4. There are parentheses on the 4 because it means it's not included. All right, we have in 7, we have f of x is 3 to the x minus 2. So this is a exponential function. The b I'm looking at is bigger than 1. So this has that basic shape. All right, there's nothing on the end, so there's no up or down. The movement is here, which means it's going to go left or right. Set it equal to 0. I get x minus 2 is 0, so x is 2. So normally it's crossing at 0, 1. It gets shifted over to the right by 2. So the new important point is 2, 1. Exponential functions don't have vertical asymptotes, but they do have horizontal ones. And since there's no up or down, the horizontal is y equals 0. So it never touches that horizontal asymptote. That's why the range has a parenthesis on the 0. All right, in our next problem, question number 8, we are looking at a log function. And looking at this log function, I see that b is bigger than 1. So it does have the basic shape of a log function. The log function normally crosses at 1, 0, normally. In this case, though, there is a shift. So x plus 3 equals 0, and I get x equals minus 3. So if it normally crossed at 1, and if I go left by 3, it would now be crossing at minus 2, 0. Normally, it's undefined when we are at 0. What makes this 0 is minus 3. So there is a vertical asymptote that you must draw there at minus 3. So the domain starts there, a parenthesis because it's not defined at minus 3. The range is down forever and up forever. So that concludes our basic graphing, moving things left, right, up, or down. Question 9. We have a piecewise defined function. We have two pieces. We have an x squared and we have an x plus 1. Now, x squared, we know, looks like a U shape. Bottom of the U is at 0, 0. This part, x plus 1, is a line. It's a line going up because the slope is 1. B is 1. So if I extended this, it would be crossing at 1. But in the piecewise defined case, we only need parts of the original functions. For the x squared, I'm chopping it at 2. So my normal u is chopped at 2. Where is this dot? Well, put in 2. 2 squared is 4. It's a closed dot because there's an equal there. On the line, we are looking at things bigger than 2. So I chop off everything to the left of 2. Where is that dot? And it is an open dot because there's no line, so there's no equal. The dot is at 2 plus 1, which is 3. So we have pieces, an x squared, a part of that, and a line for that part. All right, in question 10, we are looking to see if f and g are inverses or not. And we have to prove it. If they are inverses, then when I compose them together, I should get x back. So let's see if we do. All right, f of g, I go find g. Here's g, and just write it inside. All of this stuff goes into f. Here's f. So 2 times all that stuff. The 2's cancel, and so I get x minus 3 plus 3. And yes, I do get x back. So we're halfway done. Let's look at g of f of x the other way. So I just write in what's f. 2x plus 3. Now all of that stuff is going into g. Here's g. So just fill all that stuff in. So 2x plus 3 minus 3 over 2. When you remove the parentheses, the 3's cancel. You get 2x over 2. 2's cancel, and you do get x. So yes, they are inverses. Banking. All right, so banking. My formula is A equals principal times 1 plus r over n. N appears there as well, and t. T is for time, how long it's in the bank. N is the number of compounding periods. In our case, it was quarterly, so N is 4. See the 4 in both places, 5 years. R was my interest rate, which was 0.04. And my amount of money I'm putting in is 3,000. All right, so we want to calculate this on our calculator. 4 times 5 is 20. And we did this in class. You calculate the fraction first, plus 1 second, raise it all to the 20th power, and then multiply by 3,000. And so you then round the answer to 2 decimal places because we're dealing with money. All right, in question 12, we have an inequality to solve. It is a trapped inequality. We have a number on the left, a number on the right. Variable is stuck in the middle. And so my goal here is to isolate the variable. So I want to get rid of the 2 all the way across. Minus 3 minus 2 is a minus 5. 8 minus 2 is 6. And we do get the 2 to go away. Now we're not quite done because I still have a negative in front of the x. It's easy to get rid of. I have to divide by negative 1. But with inequalities, if I multiply or divide by a negative number, all the inequalities must flip around. And so I get a positive 5, a negative 6. All right, so we have our solution. I need to plot it on a number line. The minus 6 will get an open dot. 5, because of the equals, gets a closed dot. Closed dots go with brackets. Open dots go with parentheses. All right, so let's see. In 13, we have a absolute value inequality. So what's important is the direction the inequality is pointing. It's pointing away, and that's why I have 2 separate problems and not a trapped problem. All right, so the first problem is just like it's written. So move the 3. 6 minus 3 is 3. So I get all the stuff 3 and bigger. The second equation, 2 changes. Inequality turns around, and I've got the negative of the number. Notice it's negative. Notice the inequality is flipped around. So move the 3. Minus 6 minus 3 is minus 9. And so I've got closed dot on both places because of the equal. Everything under minus 9. And so in my interval notation, I've got brackets. Because I've got 2 pieces, I've got U for union. Question 14, we have a quadratic inequality. And our strategy there was to set it equal to 0. First, figure out what makes it equal to 0. This does factor. Minus 4 times 3 is a minus 12. If you add the middle and the outside, you do get a minus 1 in the middle. And so x minus 4 equals 0. You get 4. X plus 3 equals 0. You get minus 3. So you plot them on a number line. They both get open dots because of the inequality. And we'll finish the problem by picking one test number from each region and trying it out. All right, so to do that, I used the factored form. So I did x minus 4, x plus 3 less than 0. If I plug in minus 4 in both places, that would calculate to be a minus. That would calculate to be a minus. The product of two minuses is not less than 0. If you plug in 0 in both places, I'd get a negative and a positive, but the product is certainly less than 0. If I plug in the 5, I get 5 minus 4. That would be plus. 5 plus 3 is plus. Product of two pluses is a plus, but it's not less than 0. So we've solved the problem, plotted it on a number line, and written the answer in interval notation. All right, in 15, we want to do division. And we can do long division or synthetic, whichever you prefer. You don't have to do both. I did both just so that you could see how you would do it. So if it's long division, the x minus 5 is on the outside. The inside part, I have to look to see is anything missing. I've got a cube, I have a squared, I don't have an x. That's why I fill it in with a 0x. All right, the way the game starts is what would you multiply by x to give you 2x cubed? Well, that's 2x squared. So 2x squared times x, 2x cubed. 2x squared times a minus 5 is a minus 10x squared. But now you're subtracting. Okay, 2 minus 2, 0. Minus 7 minus a minus 10 is a plus 3x squared. And the 0 comes down. Play the game again. What times x is 3x squared? Well, 3x. So you get a 3x squared. 3x times the minus 5 is a minus 15x, and you are subtracting. All right, so let's do that. All right, so 0 minus a minus 15 is a plus, and then the minus 64 comes down. 15 times x is 15x. 15 times a minus 5 is a minus 75. And now subtract. Minus 64 minus a minus 75 is you're really adding 75. And so we get a plus 11. So my answer, 2x squared, 3x plus 15, plus the remainder of 11 over the x minus 5. If you do synthetic, the number on the outside is what makes the bottom 0. Across the top, you fill in just the coefficients. I put the particular powers above it, and so the place that was missing is a 0. The game starts, 2 comes down. 5 times 2 is 10. Add, you get a 3. 5 times 3, 15. 0, add 15, 15. 5 times 15, 75. Add and get 11. And so your answer is always 1 power less than what you started with. And so we do get exactly the same answer. So you pick whichever method you prefer. Synthetic is always faster and cleaner. Let's see, question 16. We have an equation to solve. We have fractions. And so I want to get rid of those fractions. I want to get rid of the 16, the 12, and the 3. I want to multiply by something. But the question is what? What would I multiply by that will cause all 3 to cancel? Well, let's see. Prime factor all of the bottom parts. 16, 2 times 2 times 2 times 2. 12, 12 is 4 times 3, but 4 is 2 times 2 times 2. Well, 3 is 3. To find out what to multiply by, let's see. We have 2 as a factor. The most number of 2's is 4. Another prime factor we have is 3. The most we have is 3. So 2 times 2 times 2 times 2 is 16. 16 times 3 is 48. And that's the number I'm going to multiply by each of the parts. So let's see. 16 goes into there 3 times, so I get a 3x. 12 goes in there 4 times, and so I get 4 times the x minus 7. 3 goes into 48 16 times, and so 16 times x plus 6. Now it's just a question of getting rid of the parentheses and combining like terms. Let's see, minus 4x, minus 4, minus 7, plus 28, 16x, and a 96. 3x minus 4x is a minus x. That's all I did from this step to the next. Let's see, I'm going to get the x together, so that's 16x plus x, 17x. I'm going to move the 96 over, so I get 28 minus 96. I get a minus 68. And then divide both sides by 17. And so I get x equals minus 4. 17, we are solving an exponential equation. First thing I'm looking for is, can I get the same base? Because that's always fast if it works. But 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27, and that's too big. So I can't get the same base, so I'm going to use logarithms. I took the natural log of both sides. The exponent will come in the front and multiply by the natural log of 3. I divided by the natural log of 3, and then I subtracted the 2 when I moved it over. And so now it's just a question of calculating and finding our answer. Now, do not make the silly mistake of thinking you can cancel the logs, and then 21 divided by 3 is 7. That does not work. Just calculate on your calculator natural log 21 divided by natural log of 3, and then subtract 2. All right. In 18, we are trying to solve a log problem. Let's see. I have log of something equals a number. That's just our basic property. And so 4 cubed must be the stuff on the inside. 4 cubed is 4 times 4 times 4, so 64. Move the 4, and so I get a 60, and then divide both sides by 5, and I get x equals 12. You always have to check, does this answer cause the log any problems? Remember, the domain for the logs has to be bigger than 0. But if you plug this number in, it is clearly bigger than 0. All right, in 19, we are solving a system using the matrix method. So, step 1, grab all the coefficients, the 1, the 2, the 13. 3 minus 1 and 11. So if that's all you can do, at least do that and get partial credit. So the good news is I do have a 1 in that position. I'm going to need to use the 1 to make a 0 under it. So I'm going to take minus 3 times that whole row. So I get a minus 3, a minus 6, a minus 39. I'm going to add that to row 2 here. So minus 3, add 3, 0. Minus 6, minus 1, minus 7. Minus 39 plus 11, a minus 28. And so that is my new row 2. Only row 2 is the new one. So where are we at? Got a 1, got a 0. I need a 1 in that position. But that's pretty easy. All I have to do is divide that row by a negative 7. All right, so let's do that. So 0 divided by negative 7, 0. Negative 7 divided by negative 7, 1. Minus 28 divided by a negative 7, and I get 4. So we're almost there. I've got a 1, a 0, and a 1. Finally, I'm going to use this 1 to make a 0 above it. So I'm just going to take row 2, multiply it by negative 2, and add it to row 1. So let's see. Minus 2 times row 2. So minus 2 all the way across. 0 minus 2 minus 8. Adding that to row 1, 1, 2, and 13. Add it up. I get 1, 0, and a 5. So that is my new row 1. But look, we're done. 1, 0, 1, 0. And so I can conclude that x is 5 and y is 4. And so our last problem on our sample final exam is, what does this polynomial look like? All right, well, the first thing I need to be concerned with is, what is the highest degree? Now, if I multiplied this junk out, I would get a x cubed. If I multiplied this stuff out, I'd get a x squared. And from that part, I would have an x. So let's count up how many x's. 3, 4, 5, 6. So it's x to the 6th. 6 is an even number. So this polynomial is going to be up on both sides. All right, what about the zeros? Well, let's see. What makes this first part 0 is minus 5. What makes this part 0 is minus 1. And what makes this part 0 is 3. All right, so I've got what the two sides look like. I now know the zeros, or where it crosses on the x-axis. The last thing is, well, how does it cross? And that's what the multiplicity tells me. The multiplicity on minus 5 is 3. Multiplicity on the minus 1, 2. And the multiplicity on the 3 is 1. So 3 means a snake, 2 means a U shape, 1 means a line. So let's take a look. Let's see, it is x to the 6th. So left side is up, right side is up. We are crossing at minus 5, minus 1, and 3. Multiplicity 3, 2, and 1. So there's my little snake crossing at minus 5. We come down, up. There's my little U there at minus 1 because of the multiplicity of 2. And then we're up, up, and away through 3 like a line because the multiplicity was 1. So basically, the real final exam will be very similar. How can I change it? Well, I can change these numbers, and I can change, maybe put the 3 here, the 2 there, and the 1 in the first. But basically the same idea. So if you study the sample well, watch this boring video many times, you're going to do really well on the final. So good luck, and I'm sure you're going to do well.